Refrigerant recovery is the foundation for life cycle refrigerant management, as without safe refrigerant recovery, there cannot be reclamation or reuse. A-Gas Rapid Recovery is an on-site refrigerant recovery service that gives businesses an easy way to contain their used refrigerants.
Not a whole lot of companies do what we do. We handle some of the grunt work that they don't want to do, and we can do it 10 times as fast as they can. The recovery portion, cylinder exchanges, and buying back used material that otherwise can't be used.
We play a big role with our contractors, whether that be HVAC, mechanical, or demolition contractors. Our whole purpose is to get on site and not only help them save money in the project, but offer an environmental solution.
We do not want any of these products getting vented to atmosphere, no matter how low the GWP is. Now it's not only the cylinder to recover the product, but it's making sure the technicians have equipment that are rated to work with flammable gases. That's really important for people.
So by us being able to contain it in cylinders, reclaim it, we're saving the environment one recovery at a time.
My name is Mike Idle. Today I wanted to give you an overview of Amatrol's T7300 HVAC control system. This system is designed to align a hands-on workstation, as you see here, along with interactive curriculum to teach the operation, installation, application, and troubleshooting of control systems related to the HVAC industry. As components and features of HVAC systems get smarter in both the residential and commercial fields, it's important for current and future HVAC technicians to be trained up. What types of circuits are used, familiarity, learning, operation, maintenance, troubleshooting are all important areas to cover in that.
Here at NAVAC, we are obsessed with delivering the best HVAC tools on the market. Our tools are built for professionals and engineered for precision, just like Harley-Davidson motorcycles. NAVAC Nation, it's time for you to feel the power both on and off the job site. Let's stand up in our pursuit of perfection. From coast to coast, NAVAC forges the path forward. Wherever you are, we will be right beside you.
Good afternoon. Thank you all for joining us again on Did You Know, the ESCO HVAC show. We are so grateful for our sponsors that have helped us build this incredible new studio. We're going to be spending some time diving deeper into technologies and innovations in our industry, and it's just a wonderful time to be in HVAC, refrigeration, building sciences in general. Thank you all for joining us. Hey, great to have you in here. Kendrick, how are you doing today? Yeah, there's going to be a lot of fun things today. We're going to be diving into some A3 refrigerants. We're going to really talk about the refrigerant transition and the proper resources for you to be successful in the classroom, out in the field, and a lot of fun topics to talk about. So for those of you joining us, we're hanging out today with Jason Abjute and Patrick Murphy from the team. How's it going, guys?
Good.
Hello, everyone. Good to be here.
So for those that don't know, Murph has been in the industry for a long time in these A3 refrigerants. Murph, give us a little background of your history working with A3 refrigerant training.
Well, when I was at RSES, I developed the first A3 training material that they had. And that was back in 2012. And then I left RSES and went with a major manufacturer who decided that they were only going to use propane in all their equipment. So they eliminated 3 different refrigerants that were in their manufacturing plant, and everything went to 290, and they've been shipping it all over the world. And I spent 5 years with them until COVID hit, doing the training throughout the Northeast, from the Virginia border, the Canadian border, out to Pittsburgh.
Yeah. So for those that have ever been in a true training program or went through any of that content, Murph is right behind all of that. And Jason has been in the A2L side of things since it began, sitting in on the Safe Refrigerant Transition Task Force, working with all of our instructors, codes, regulations, building our A2L training curriculum. And so now we are excited to release a new A3 program for all of you. Hot on the press. We're going to be diving into some of the curriculum today, and it's really about getting prepared for this next generation of refrigerants. I say next, but like Murph said, we've already been with them for over a decade, but now we're starting to see them in a lot of different applications. Most of our commercial refrigeration are smaller capacity systems from I've seen all the way up to 3-door reach-in freezers now using R290 or 600A, depending on the application. All of our residential products, all of our refrigerators and freezers have all went to an A3. Yeah, you're right, Paul. They're all going that way. It's either 290 or it's 600A, everything out there. And so it's going to be important for us to start moving into A3 training. One of our sponsors for this studio is iConnect Training, and we're actually going to be bringing in an R290 heat pump trainer. Huh? How about that? Talk about refrigeration. It's actually going to be a refrigeration unit with a heat pump, and it'll all be easy for us to get in and actually work on the controls and understand the operating parameters for it. So it's about being safe and knowing the curriculum. So let us know in the chat where you're joining in. Let us know if you've been introduced to any of the products. I see Paul Leonardi, he's already aware of the residential side. And then we're going to dive into the curriculum a little bit today. And so Jason, tell us about this program. I know it's been in process for quite a while.
So we started doing some research for this, like you said, a couple years ago, and moving along with it. We got the A2L out first because that's the equipment that the contractors are going to see immediately was the A2Ls. And after we got all of that settled, we moved back into the A3. There's a lot of research into this book, into this program, with different manufacturers and the different codes and some of the requirements and things. So it finally came together. We got it all together. It's not going to be the biggest book. It's a smaller book, but it's loaded with information from cover to cover. Everything in there is informative. It's either about codes or about design or about what type of oils are being used, what refrigerants, what applications, what charge sizes. There's a lot of stuff in this book that are necessary if you're going to be working in this.
Absolutely. Katie, thanks for joining in from Missouri. Glad to have you with us today. All right. So when we make this transition, we start working with these refrigerants. It's going to be important that we have not just the books for the classroom, but the PowerPoint presentations. We're actually working on a certification that goes along with that. So let's start with an introduction into A3s. This is actually the PowerPoint presentation that goes along with the curriculum. We're not going to go through all of it. We're just going to spend a little bit of time diving into some of the beginning topics, and then but there'll be a lot more for us to jump into. So let's kind of talk about the different topics covered within this curriculum.
There's quite a bit, as you can see in this slide. There's a lot of things that have to be reconsidered when you're dealing with a highly flammable refrigerant. There's some exemptions from the EPA as far as recovery is concerned, but all of the other service practices remain in place. There's some specialized tools, replacement parts, component design. Those things are designed specifically for these systems. And as you mentioned, they're mostly packaged systems, corded appliances, whether they be residential, freezer, refrigerator, or on the commercial side, 2-door, 3-door reach-ins, or prep tables, those sorts of things. With the technology transition rule that was passed under the AIM Act, a few of the subsectors, is January 1st of this year, they had to be under 150 GWP, vending machines and those sorts. So that doesn't leave a whole lot of refrigerants to choose from when you have to be under 150. So most of them went to either 290 or 600A, which again are A3 hydrocarbons. So there is a lot to cover here.
Yeah, absolutely. Paul, I'm glad you've already hopped on this bandwagon. Man, he is right in front of it. Glad that you got that.
Nice.
Yeah. And
Great.
so any questions or comments along the way, just let us know, Paul, because that's the reason we're doing this. Is a lot of instructors are going to be looking at this going, wow, it got here faster than I anticipated. There's not a lot of content out. And oh, wow, ESCO's already got the content going, which we
And
normally
we will
do.
have an exam soon. Murph and I are working on the certification exam as well, and a practice test.
Excellent. We pride ourselves in staying ahead of the game here at ESCO, making sure that we're helping you be prepared so that you can be comfortable with the products before they actually are introduced into the industry. And this is one of them that is just flooding into the market. I was looking through all of our classes for our conference this year at the National HVACR Education Conference. By the way, this will be our 20th. So it's going to be 20 years of HVAC excellence. One of the classes was, A3s in residential HVAC equipment. What does that future look like for us? Will we see A3 refrigerants in the residential? Well, we already see them internationally. So the chances of them coming to the United States, it's inevitable that we will see them in residential, not in split systems, but in packaged air to water monoblock style systems. So we need to get comfortable now on our smaller ones, especially getting into the regulations, because there's a lot of changes when we move from A1 to A2Ls. When we go from A2Ls to A3, it's another story. There's a lot of things that we're going to have to be focusing on.
Before we jump into this, there was a lot of industry participation in this. A lot of people were very willing to say, here's some images, here's some information, here's some manuals. The manufacturers were very gracious with their time and with their information. So I just want to shout out to all of those that were really embracing this, trying to get this information out.
Yeah, I know just the ones that I've talked to, every time I'd reach out, hey, you got any curriculum you'd like to get to the industry? And they're all going, yes, whatever. We got to get everyone prepared for this. It's like, it's here and no one's aware. And the ones that are struggling to tell everyone how to do it right. And I was like, okay.
Yeah, there's a lot of bad, and I will say this, there is a lot of bad information out there.
Yeah.
We saw that with the A2Ls when we were making the transition. That was a lot of bad information out there. And there's the same thing with this. There's going to be, and if your primary source for information is social media, we're going to have an issue because there's a lot of bad information there.
That's right.
A lot of people look at it and say, oh, well, this is flammable, I don't want to use it. Well, we've all been working with products that can be flammable for years. Anybody who started in this industry all the way back when I started, you had a torch in your truck.
Yeah.
You were working with a flammable device at that time. So safety becomes a critical component. If you work safely and follow good, safe practices as a refrigeration technician, you shouldn't have a problem with a hydrocarbon refrigerant. If you start using shortcuts, then you have another problem.
Exactly.
I will say one of the big differences from working with an A2L to an A3 are the charge size restrictions. They're like with A2Ls, we do have a charge size restriction in place, but it's a moving target.
Right.
It's dependent upon the cubic volume of the installation space and all what mitigation you have installed.
Right.
So depending on how the system is designed, you can get into very large charge systems. This one, there's a hard limit in place, and no matter where you're at or what you're doing, you can't go above that limit, no matter what the system design is. So at the moment in the codes and standards, there is a very hard limit in place for these. So, and we charge these by weight into a sealed system. So the other thing I want to point out is we've been talking about A2Ls and A3s, and a lot of people, okay, it's flammable. I want to say this, just because a refrigerant is flammable doesn't mean the refrigeration cycle changes.
No, absolutely.
Superheat is still superheat. Subcooling is still subcooling. It is the same refrigerant cycle that you're working on right now.
I just wrapped up a podcast with Joey Henderson, Jojo, the HVAC man, maybe 2.5 hours ago. And the conversation was just that. And it goes back to one of the statements that Howard has mentioned before, and it's always stuck with me. Our next refrigerant, it might be milk. Our job is just to teach you what milk looks like in a refrigeration cycle, because we're always going to see new refrigerants. We're always going to see changes. And for us, it's a matter of preparing you for what those differences are.
Eventually, we'll go to 718.
Yeah, absolutely. It's a great refrigerant. Doesn't like water, but
You know,
Yeah.
So when we look at some of our refrigerants, let's understand what's happening as we go to hydrocarbons. A lot of our refrigerants have their foundations as hydrocarbons and have went through chemical processes moving away from those. Now, when we start looking at some of these natural refrigerants, and we call them natural, some of them are synthetic, constructed chemicals, but they're from a natural base, a natural design, which is why they have such a low global warming potential. In most cases, zero ozone depleting potential. But let's look at our two primary candidates and see what we're actually working with here so that we've got an idea chemically wise. Like, what do we got?
So in a lot of these refrigerants, you're going to see two of the primary components in the refrigerants you're using today, carbon and hydrogen. The only difference is some of those hydrogens have been replaced with fluorine, which does bring down the flammability, but it does raise the GWP. If you leave the hydrogens in there, that's where we run into the issue. Okay, now we have flammability, right? But we do lower the GWP of the refrigerant. This is a more natural form of each of these substances. But I do want to make abundantly clear, this is not the same propane that is in your grill in the yard or the same isobutane that is in your cigarette lighter. They are refrigerant grade chemicals. They have been purified to AHRI standard 700, so they don't have any odorants. They don't have any other contaminants in there, no other hydrocarbons. So they are, it does not, if you were to look at the two under a microscope, an electron microscope, regular propane and refrigerant grade propane do not look very similar to one another.
Okay. That's good to know.
Meeting the purity standard is critical.
Exactly.
Because if it doesn't meet the purity standard, there's going to be moisture in the refrigerant, and all of a sudden it's going to be contaminating the system and causing corrosion inside the components.
So, for example, propane has multiple grades. You could have heat or fuel grade. There's a chemical grade. There's a refrigerant grade. And what changes is the percentage of impurities that are removed, correct? So in its naturally occurring form, you may have other hydrocarbons present, or you may have mercury or some other chemicals that are present in there that have to be filtered out. And again, depending on what it's being used for, it could be heat grade where we're burning it. It could be chemical grade. It could be industrial grade, or it could be refrigerant grade.
Very intriguing. Paul, will we need new leak detectors? And I imagine you're talking about handheld refrigerant leak detectors. And so we are starting to see, originally we started looking at it going, okay, well, we can use our combustible gas detectors, but now we're actually starting to see multi-refrigerant detectors that do a variety of refrigerants. You select between different sensors, which I think is really cool. So we're going to see a variety of those. Tony, you haven't seen any of ours yet. Okay. So this is what I always tell people. The next time that you get a chance to go through any of your big box shops, Lowe's, Costco, Walmart, take a look at any of your refrigerators or freezers of any size, and you'll find that they have all went to
90% of them were 600A prior, but as of January 1, 2025, and the technology transition rule, they all had to transition to something below 150. Yeah. And everybody went for refrigerators. We're seeing mostly 600A.
Yeah.
But you might see some 290s, especially in the mini fridges and those sorts of things. But it's like 2.6 ounces, 1.8 ounce. Yeah. I mean, and look at how well it works, how cold that freezer gets, how cool the refrigerator stays with just 2.6 ounces of a refrigerant circulating through there. You're moving all of this heat. I mean, it's a very efficient refrigerant, low electrical consumption, good at moving heat. Very miscible with either mineral or POE oil, except for the flammability. It's a really good refrigerant, both of them.
And it's not a new refrigerant. One of the real early shows we did, we went through some of the history of refrigerants, and we used propane back in the late 1800s. We used gasoline as early as 1870 in some of our mechanical refrigeration systems.
I think there's a slide in there, Clifton, about the propane refrigerators from the 30s in the PowerPoint.
Absolutely. Very cool. So, a lot of the refrigerant has been out there. It's just now we're getting to understand the awareness of it. And it's not just our industry that's going through a transition. One of the things that you will see when you're looking at some of these new refrigerators and freezers, especially the residential and the light commercial, Even the foam blowing applications were demanded to go into a lower GWP refrigerant. So a lot of the residential and light commercial applications that you will see these hydrocarbons, you'll actually see an additional one on there on the sticker that says C-pentane, highly flammable. And that is not the refrigerant. That's actually the gas that's being used in the spray foam for the foam to expand. So not only do we have A3 highly flammable gases inside of our refrigeration system, we have some that are slowly degassing in the spray foam of the shell as well. So a lot of research, a lot of science, a lot of safety precautions have went into this, and that's why we need to know, like, what are the safety precautions. And that was really the goal behind this project, is to prepare us for safely handling, working on, and disposing of these next generation of refrigerants.
So there's no federal requirement that says, listen, you need to take this training on this refrigerant.
Right.
There's no restriction, like we have our 608 card to buy all of the CFCs and the HCFCs and the HFOs. You don't need that for propane. These are exempt refrigerants. It would behoove you to obtain some sort of before you start working on this. I mean, it could end very badly for you.
Yeah.
I mean, there's plenty of videos online of that happening. So we're trying to say, listen, here's the information. Here's what you need to know. We've done all the research. We've got cooperation from the manufacturers, and we're trying to present it to you in a manner that you can take it all in and say, okay, I feel comfortable now. I would say the goal of this is to quench the fear. If you're working with electricity, you shouldn't fear the electricity. You got to respect it. That's the safe way. Same thing with this refrigerant. When you see the big scary sticker on there, you can't have that fear, or you're going to make a mistake. So we want you to feel comfortable with this.
Yeah, because especially in our commercial refrigeration, I know even a lot of our smaller, I think it was under 250 pound or 300 pound ice machines, they're all going A3. All of your ice chests that sit out in front of your gas stations, and the Lear ice chest, talked to Lear some months back, and they're all A3 highly flammables now. So the hydrocarbons really are moving into the refrigeration sector quite rapidly.
That slide you just put up is a big one there. A lot of folks don't realize that there is no odorant. That the odor that you have in hydrocarbons, whether it be natural gas or propane, is put there through a stenching process for leak detection. But it is a contaminant in refrigerant systems, so we don't have an odorant in this. So you can't smell a leak with this particular propane.
Wow. Yeah, and it comes into play of having the proper leak detection for sure.
Yes, you should walk in, when you walk in to work on a system that's hydrocarbon based, the leak detector should be turned on before you even walk into the building or walk into the space where the unit is. Because if there's any leak, it will start to detect it. The leak detector should not be shut off while you're working on the piece of equipment, so that you know there's been no problem with any leaks while you're working on the equipment.
The other issue is these are heavier than air, so they're going to collect along the floor and in low places.
True. I hadn't thought about that.
So mechanical ventilation, they're not going to naturally dissipate like natural gas would.
Right.
These refrigerants are going to collect on the floor. So some sort of a mechanical ventilation with an intrinsically safe fan to move air through there, something along those lines.
There
was actually one case manufacturer, I believe from Europe, who decided that to prevent an issue with a collection, they would leave the condenser fan run all the time.
Makes sense. No, I get that. And there's a lot of scare within the industry, maybe not so much from our side. I mean, there's a lot of stigma with going to a highly flammable refrigerant. But for those that are not accustomed to being around refrigerants like these, there is a lot of, there's a lot of caution, and there's a lot of misinformation. And so what we really are trying to do is help you get comfortable working on this, and to be able to communicate with those around you. Jason had his own experience with people not understanding the flammability of refrigerants and not understanding the quantities of refrigerants, and ran into a scenario where it wasn't even allowed to work on a piece of equipment inside of the building. They wanted it outside, they wanted it out of view. And that's not really the case. It's understanding what the actual safe handling, safe practices are is what will get us all forward.
I will point this out though, that there are a lot of spaces still today. If you have a 290 system, a 600A system, let's say a college campus, you have a cafeteria, you have the kitchen, and you have these refrigerators and freezers. And if they're 290 and they need to be repaired, there's still a requirement that your company come pick it up and take it off location, repair it, and then bring it back. They don't let you fix it on the location, which I find pretty funny because the person that's going to load it onto your truck is driving a forklift that has a 30-pound tank on the back that they're burning, correct?
That's
and
right.
There's 2.6 ounces in this unit. But a lot of the college campuses and certain data centers and places like that, they have a requirement where you come pick it up, you put it in your truck, remove it, leave a loaner possibly while you work on the unit, and then bring it back.
Yeah, absolutely. One of the questions came in from Paul is, what is the max charge in a unit currently? I know there's some information on that later in the presentation.
So we got to be a little more specific on, are we
If it's
talking
an open
commercial?
case,
Yeah.
if it's
Is
an
it
open case,
residential,
you're allowed
commercial?
494 grams, which is 17.4 ounces. I just
A
opened
little
the
over
book
a
and left
pound,
it
yeah.
next to me.
It's still quite a bit of refrigerant. I mean,
So let's say on our refrigerators domestically in a residential setting, it's still 150 grams. That has not changed. That will not change in the near future. However, on the commercial side, through the SNAP rulings and through the UL 2-89, it has been updated for larger charge systems in commercial settings specifically, depending on if the system has doors and drawers or if it's an open where you can reach in and grab the sandwich type system. So they have been updated, and we will start to see these larger charge systems hitting the market very soon.
You know, I think this is a really important slide for us to recognize when we're looking at refrigerants. You mentioned this before, and I ran into this a lot the last few days. We actually spent Monday and Tuesday with Hudson Technologies over in Champaign, Illinois, going through the entire life cycle of a recovery cylinder and the refrigerants that we recover, right? The entire process. And one of the things that they pointed out was they have to test at many different places along their processing to make sure that they're meeting the AHRI 700 standards. So when we're looking at refrigerant, it's critical that we are making sure that it has been approved and stamped that it meets the AHRI 700 standard, but especially as we start looking at things like the R290 because it's
available online. If you were to like go online to look to buy propane as a refrigerant, use a trusted source. Like you were saying, it's an expensive process to test the refrigerants to ensure this purity standard. So if you find something that's like dirt cheap and seems like a good deal, it might be too good to be true.
Yeah, we've seen that even with our A2L refrigerants. You know, as we start getting into the A2L transition, we've had refrigerants being sold from international manufacturers coming in that are not AHRI 700 certified. And as they start making their way into the systems, they're introducing moisture, they're introducing contaminants. And that's really what we're wanting to be concerned with as we look into these generations of A3 refrigerants. The same thing.
We've
Purity
also
is
seen
important.
on the A2Ls, just a side note, that some of them are coming in the wrong cylinders. They're coming over with a rupture disc rather than a pressure relief valve. So always buy from a trusted source, somebody that you trust to have the quality stuff, the right stuff. Especially when it comes to something like this.
Yeah, indeed. All right, let's talk a little. I guess we kind of brush on it. Let's talk a little bit about the history, and understand that we're kind of we're back full circle again now with our A3s. Murphy.
Yeah, I was going to say, Murph, you can talk about this.
Yeah, but I have no problem talking about it because, quite honestly, older systems like this, because of the way they were built. And, if you tried to move a refrigerator from the early 1900s, you needed some strength.
Yeah.
And they were built very sturdily and they lasted a long time. I actually know of a system that's probably 5 miles away from me right now that will never be repaired because it's an ammonia system.
Mm-hmm.
And it's in an absolutely gorgeous estate. But the 290 has been used. It was used way back in the 1800s, in the mid 1920s when they developed R12. That's when things started to shift away from the natural refrigerants. And as we continue to develop 12s, 22s, 502s, 454Bs, continue with all the different numbers. All of a sudden we looked at it and we said, oh, we've caused problems with the ozone. We've caused problems with global warming because of our refrigerants. What can we use that doesn't cause that problem? And that's the hydrocarbons. Yes, they are flammable, but I don't find them to be any different. As Jason said earlier, it's the same refrigeration process. You have a compressor, you have an evaporator, you have a condenser, you have a metering device. It works the exact same way. Naturally, everything has to be R290 rated. All the controls have to be 290 rated, flammable rated. You can't just go picking anything off the shelf and put a new thermostat in, because if the leak is inside the cabinet and the door is closed and you've thrown a regular thermostat in there and it creates an arc and the refrigerant has gotten to the lower flammable level, you could have that refrigerant ignite, because it's much easier to ignite the hydrocarbons, the A3s, than it is the A2Ls or the A1s. A1 refrigerants do burn. They just don't support combustion. You have to hold a torch to them, because I can tell you, I've done it a number of times and paid for it with the smell. So
I'll tell you,
it's just a matter of,
go ahead.
Just work carefully with it.
So the millijoules for ignition for 290 are like 0.25 millijoules. And when we look at, like, let's say 1, 2, 3, 4 YF, it's 5 to 10,000 millijoules.
Right.
So 0.25 is roughly static. If you rub your feet on the carpet and you touch somebody, that's about 1/4 of 1 millijoule. That is enough to ignite if you have the proper mixture of fuel and air. Yeah.
Right.
So you're right. It does really matter. The controls, they have to be intrinsically safe and they have to be certified to work with those refrigerants.
And if you're below the lower flammable limit or above the lower flammable limits, it won't ignite. So you could have an instance where somehow there's been a leak and it's been contained and you're way above the upper flammable limit. And then all of a sudden you open the door, you've changed the flammable limit inside that cabinet by introducing air. So you have to be very careful to make sure you use the proper controls.
Yeah, we've actually had some instances or quite a few reports. I did some research. It's probably been 6 or 8 months ago on some residential refrigerator explosions that have happened around the country. And at least on 2 of the ones that I did research on, the evaporator fan motors have been replaced by a contractor and replaced with non-intrinsically safe evaporator motors. They were just put in standard shaded pole motors and had enough arc on startup that actually ignited gas leak in 2 of them. So but those were systems that had leaks and had wrong parts on them. The chances of finding that are slim, but all it would take is one improper repair, installation, or service, and then we do have some of those potential issues. And we mentioned previously, one of the main reasons that we're looking at our lower GWP or natural refrigerants, including things like CO2, as well as these A3 highly flammables, is the environmental impact, right? Looking at ways to use more environmentally friendly refrigerants. And so as we go forward, we're going to see a lot more use of these natural style refrigerants.
So this is an important slide. Again, it comes from looking back at the technology transition rule and what these manufacturers are going to have to work with in the different applications: 700, GWP, 300, 350, or 150. If you look, a lot of the package refrigeration, ice makers, refrigerators, freezers, reach-in stuff, quartered appliances, a lot of them, they specify 150 or less. Well, if you look on there, all that leaves
Not a lot of options.
Yeah, 744 CO2 doesn't work well in those package systems like that. So you're looking at 600A and 290 for a bulk of this.
Yeah, a lot of these other refrigerants, those that we are very common with, are, if not already gone, are on the phase down. You got to remember, we are in an HFC phase down currently. We will be through 2036. In 2029 will be, or 28 or 28. 28 will be the next step.
29.
So at the end of 28, January 29, we'll be taking that additional 30% step.
That's a cliff right there. That is the cliff that everyone's worried about. Yes.
Exactly. And so that just really gives us a few years to make a pretty swift transition into other refrigerants, because some of these higher GWP refrigerants like R22, gone, hasn't been made since 2020. R134A, out the door in residential, in automotive, in refrigeration. 404, out the door. That was our low temp freezer refrigerant. It is pretty well gone. There are states that are already banning the use of it, and it's not used in manufacturing anywhere. R410A, we already see what's happening with it. It's on the way out. And we will, in the next decade, see a phase down even of our R32 and R454B that we're moving into currently. So we have to be very well prepared for these transitions and understand why. So yeah, this is a really, really good slide to understand, why are we moving to these highly flammable refrigerants?
And what does it leave, right?
Yeah.
I mean, when you look at the GWP limits, it doesn't leave us with a whole lot.
No, I mean, we've got HFOs out there that we're working with now, and that's, one of the blended piece components of our 454B. They're, newer emerging refrigerants. They've been out for a very long time, since 1960s in some of them, but we haven't utilized them as standalone refrigerants and blended refrigerants until recently. So we're doing a lot of watching and monitoring to see how the HFOs actually do long term. But we can already
a lot of those are A2Ls as well.
Exactly.
Yes.
So moving forward, most of the refrigerants that we're going to deal with are going to be flammable in one form or another, either A2L or A3. You have ammonia, you have CO2, 290, 600A, and a lot of the HFOs like 1, 2, 3, 4YF, they all have some degree of flammability.
Mm-hmm. Yeah, absolutely. All right, so let's get into some of our awareness, some of our safety precautions while working.
This is what we were speaking of earlier, that these refrigerants are heavier than air, and they're not going to dissipate, let's say, on their own. They can collect along the floor. This is an intrinsically safe fan. Don't just turn any fan on. If you're going to use ventilation, use an intrinsically safe fan that won't ignite anything that's sitting on the floor.
And for those that are not familiar with the word intrinsically safe, I know we've been using it a little bit more over the last few years in the residential applications as we move into A2L training. As we move into these A3s, it's very important to understand what that means.
So an intrinsically safe component is something that is tested, certified that it can't be an ignition source in a flammable atmosphere. So any kind of motor, any kind of contactor, anything along those lines, anything that's certified intrinsically safe, all of the arcing, all of the contacts are sealed in some sort of enclosure to where even if there was a natural gas or a propane leak, it could not cause ignition, which is why when you were talking about the refrigerators earlier, when they swapped the motors out, that motor just turning on was enough to ignite it. But an intrinsically safe motor, everything's in an enclosure and it can't be an ignition source in a flammable atmosphere. That's what intrinsically safe means.
Awesome. Yeah, thank you for that, Jason. I just think it's a very good point to bring up for those who may not understand what that actually is.
This is what Murph was talking about.
Yeah,
this is what I was talking about before. If you go into a work area, you have to have your leak detector turned on. We have refrigerants that are heavier than air. They can fill the room. But with the amount of refrigerant that's going to be used in these particular 290 cabinets and 600A cabinets, it's probably not going to reach the lower flammable limit, depending upon the space that it's in. Mm-hmm. But you still need to have the leak detector on, because if you're starting to work on a piece of equipment and the condensing unit is on the floor and you lay down on the floor next to it and it is in a small, let's say, storeroom, you could wind up being asphyxiated. Exactly. Because you're breathing in nothing but the propane. So the first thing you do as a safety factor is you walk in. Before you walk in the door, you turn the leak detector on so that it's sniffing regular air. And as it walk into that room, you're going to get any leaks that may be there. It may have already dissipated. And when you get to the unit and you tap into the unit, there may be no refrigerant whatsoever, and the leak detector's never gone off.
Right. And actually served its purpose. I've talked to quite a few different tool manufacturers in the last few months, asking what they're doing to prepare for this. And it was interesting. I'm glad that Paul had mentioned that earlier with the leak detectors, because I have seen some manufacturers decide that, hey, we're just going to go ahead and produce a different leak detector that has different parameters than our combustible gas detector. It's designed more specifically for the lower LFLs of the A3 refrigerants. And then other manufacturers decide that they're going to incorporate that sensor into their new models of refrigerant detectors so that it covers all classes, A1, A2, A2L, and A3. So it will depend on the manufacturer itself.
So this is what we say. We've been throwing around the words A1, A2L, A3. What does all of that really mean? This comes back from ASHRAE Standard 34. A and B are for toxicity. A is low toxicity, B is high toxicity, and then the flammability is the number 1, 2L, 2, and 3. So if I'm a refrigerant manufacturer and I have a refrigerant that I want to sell to the public, let's say, the first thing we do is send it to ASHRAE, and the first thing they do is set it on fire. I mean, that's a job that I probably would be
That'd be
good
fun.
at.
Yeah,
That's something that I think I would want to do.
Right.
But they're looking at things like burning velocity, heat of combustion, LFL.
Yeah.
And again, based on how it performs in the flammability test, it gets grouped into one of these buckets. One of the things I like to point out to people is that ammonia is a B2L.
Right.
B for toxicity. So when I say ammonia, the first thing that comes to a lot of people's minds is, oh, that's toxic.
Yeah,
yes,
exactly.
it is.
Yes,
But
it is.
it could also be flammable. It's a 2L refrigerant. It's just that when we're classifying these refrigerants, it's which hazard becomes acute first. And
Right.
it's the toxicity that becomes acute first. You wake up dead, right? Long before it's flammable. That's not a good way to wake up. So we have been working with a version of a 2L refrigerant for quite some time.
Right.
Because ammonia has been out there for decades.
Yeah, absolutely.
I don't
Well, that's
think they
another
ever
one of those.
stopped using ammonia.
No, that's 100+ year old refrigerant. And it brings up another point I thought that we should mention real quick. Another reason why we're seeing so many more applications of these A3 refrigerants comes down to what the manufacturers can produce. If I'm a refrigerant manufacturer, I am actually given Jason uses this term all the time, and it's perfect. They're given a piggy bank of GWPs, right? This whole phase down is not based on pounds of refrigerant. It's based on GWPs as a physical component, as a noun, right? So when we look at manufacturers of refrigerants, manufacturers of equipment, they look at it as, well, what is going to be the most cost effective for the end consumer, inevitably. So yes, we're increasing the flammability, but at the same time, we're generally able to reduce the cost of the refrigerant significantly over some of the previous generations. So if we look at things like, we would have seen 134A in a refrigerator a few years ago. Very, very common refrigerant for medium temperature applications. I've seen it in some low temp, but primarily medium temp. So most of your refrigerators, whether residential or commercial, used a 134A refrigerant. Now, if we look at, say, the R600A with a GWP of 3, and we look at the 134A with a GWP of 1,430, what that means is, as a manufacturer, if I'm looking at the GWP, I can produce a lot more R290 than I can 134A. Like prime example, like 744, right? CO2. I could produce either 1 pound of 134A, or I could produce 1,430 pounds of 744. Based on the GWP allocation. So the cost of the refrigerant is typically lower as we get into the lower GWP, especially in these naturals. And I just think that's something important for people to understand, that it's not based on pounds of refrigerant. It is truly based on GWP total for the chemical manufacturers.
So they get a deposit, if you will, into the bank of these credits. And each tank of refrigerant they make is a withdrawal from their credits.
Yeah.
And the amount of the withdrawal is the GWP. All right. So if I make 290, it's a withdrawal of 3 credits. If I make 134A, it's a withdrawal of 1,430 credits. When I'm out of credits, I'm done making refrigerant for the year. So as a manufacturer of refrigerants, I have to, okay, what do I want to make? What can I make? And, you know, so that I have enough credits to produce refrigerant until the end of the year to sufficient quantities. It's up to them how they want to spend the credits, but that is essentially what they're doing. They have to plot and plan how they want to spend their credits to make these different refrigerants. And as you said, you can make way more of this one than that one, and it keeps the cost down.
Sure. And this is a good chart that shows us some of the different refrigerants that falls in some of these classifications that we were just talking about. And as you can see, you know, we'll see those R290 and R600As up here as low toxicity, high flammability. And then some of our more recognizable refrigerants we've seen in the past, like our R22, R410A, R134, those all are in that lower toxicity, lowest of flammability. So we don't have a lot of different refrigerant options, and we have a very small window.
I will also point out that a lot of folks like to refer to A1s as non-flammable. That's
Right.
non-true.
Non-true.
All right. In a house fire, 410A burns just fine. It's under normal operating conditions, under a very specific set of conditions, they will not propagate a flame. That doesn't mean that they're not flammable across their entire range. Again, in a house fire, whatever refrigerant's in the condenser is going to be fuel for that fire as well.
You bet. When we have high temperature, and so we get our high ignition point, we have high concentration. This is a fun chart. I really enjoy this one.
I spent a lot of time on this in class, yes, when I'm teaching the A2L classes.
Yeah. So what we're talking about is, you know, how do we base these different refrigerants? Because even if a new refrigerant comes out, how do we actually compare it? And so in the actual test standard, we're actually using refrigerant, we're using air, and we're using ignition to see how much it will ignite. So when we started talking about these A2Ls, we always say that they're so much closer to A1s because of their ignition point. And this is a really good visual to understand that. The jump from A2L to 3 is incredibly different than the going from an A1 into an A2L.
This is why there are hard charge limits in place for A3s, and we kind of have a moving target on the 2Ls.
Right.
Well, you're looking at that arc, that V that you see on the screen, and they're looking to see, this is, again, one of the ASHRAE tests when they set it on fire, some of the stuff they're looking for. Mm-hmm. They're looking to see, does it break the arc on either side? And if we're inside that arc, if you look at the 2L refrigerants in the center there, barely breaks the arc on both sides. And that first one could be 134A or 410A. That's an A1 refrigerant there. And it's still, there's a flame in that picture. I try to show this to people and say, yes, this is your A1.
You bet.
This is a perfect example of they can burn. They, under the right circumstances, they will definitely burn. But as you mentioned, the 2Ls are way closer to being 1s than they are 3s. There's a big difference between 2L and 3, which is why we use different tools, different standards, and different charge limits. We can't just take all of these refrigerants and throw them in the flammable bucket and treat them all the same, because they are not the same.
Yeah, you're right. And mainframe, not sure how you want to pronounce that. Yeah, you're right. With the different refrigerants, it does come down to that combustion temperature, and we can ignite at a lower temperature and lower ignition energy with our A3s, which is why it's very important to understand the safety of it.
So that's why when you're working on a piece of equipment and you know your circuit is just as it's been for anything that you've ever worked on before, as you start to work on it, you've checked to see if there's any leaks. Now it's time to find out what's the matter with the piece of equipment. Well, if it's an electrical control, lock out, tag out, change the equipment, put the proper manufacturer specified equipment in the unit, and then bring it back online. But if you get to a piece of equipment that's out of refrigerant, but you're not sure it's not doing its job, but everything else seems to be okay, you can hear the compressor hum. Now you all of a sudden have to make that decision. Well, I guess I have to tap into the system.
Sure.
And at that point is where most people seem to have the issue with, oh, I've got to tap, this is flammable, it's going to cause a problem. Well, we've all been tapping into systems for years, and you could see before the A1 and the A2Ls, You've tapped into those systems before. And when you tapped into the system, you didn't have a problem.
Yeah, the sky didn't fall.
Right.
The sky didn't fall. So you've tapped into the system. The system doesn't seem to have the right amount of gas in it because it's not performing. You do not top the system off. You take all the refrigerant out. If you have to, take it outside, dump the refrigerant, or figure out a way to get the refrigerant dumped outside so wherever you're working is not going to cause the lower flammable limit to be reached. And then you tap into the system. Same way you've always tapped into a system. You put the tap line on and you figure out, okay, I have a leak. I have to pressure test it. You build the pressure up, you find your leak. You may be using bubbles, you may be using a sonic leak detector, but you find the leak. When you repair the leak, one of the most critical things that you can do is to run nitrogen through the system as you're repairing any leak. The reason being, there could still be a pocket of propane inside the system, and it
In
could
the oil,
ignite.
right?
And the oil that's inside the system. You also, if you have to replace a component, you do not take it out with a torch.
Oh,
You
yeah, great
cut it
point.
out.
We cut them out, right?
You have to cut them out, because if you don't cut them out and there's any residual in there, what are you going to wind up with? You're going to wind up with a flame.
A flare,
flame
yeah.
It'll shoot through the entire system and could cause you even more contamination in the system. When you access the system, you've charged the system. How do you charge the system? These are all critical charge systems. They have a specific weight. It's on the label. You don't go over it. You don't go under it, because you have to have the exact amount of refrigerant in the system to get the proper superheat and the proper subcooling.
I'll say the tools that they have came out with and developed for the A3s are awesome.
Yes.
They make doing what you said very easy. The scales, you connect the tank, program in what charge you need. There's a solenoid that opens, allows the refrigerant to go in, and you get the exact right charge. It's they're awesome is all I can say.
Yeah, and I know we cover some of that, and actually we're getting close to the end of the show. So I think let's kind of talk about some of this access. Like you mentioned access before, and we've seen some of these photos. Tell us a little bit about what we're going to see on these R290 and 600A
The
systems.
290 units are going to have red sleeves on them to designate that there's a flammable refrigerant in it. Now, the cap that's on the end of those access tubes literally is manufacturer installed. I don't know if you can buy them in the field, but you're going to have to take that red sleeve off. You're going to have to tap into the line. And the tap lines that you just saw, please don't ever leave them on any piece of equipment, flammable or not flammable, because they leak. I can tell you the manufacturer that I did the training for 5 years, they bring pieces of equipment back, and the first thing that they see is the tap line is still on, and they pressurize it, and there was the leak. So
These are temporary fittings. Yeah, they're not meant to be, right.
Right. You tap it. If you have to take the sleeve off, you take the sleeve off. You put it back on after you're finished. Charge it by weight with the proper scale. Make sure you don't exceed it. Then let the system run. Let it get down to roughly close to temperature and steady state. After it's near steady state, then it's time to take the tap line off. You don't use wire nuts. You just don't, because they can pull off.
Right.
How many of us have seen wire nuts fall off pieces of equipment, no matter what?
Yeah, absolutely. So we're going to see different electrical connector requirements.
Intrinsically safe. This is that intrinsically safe. Yes. There was a question that came up, Clifton, about using what kind of hoses.
Yeah. Yes. Going to bring that up. Great question, Paul.
We do have images and pictures and things in the book. Yes, they're really small, 1/8 inch. If you're going to use a hose at all, they have a single manifold with a little connector, a brass connector. We're not using, the entire charge of one of those systems would fill into one of those hoses, and you'd empty the entire system if you hooked up a regular gauge manifold to these. So we're using specialized equipment for this, very small, most times there aren't really any hoses. If there are, they're the little 1/8 inch fittings and hoses. Yeah.
Do we have any pictures in the presentation on those?
Yes.
Okay. Let me hop through real quick and then
Yes.
we'll come back on those, just because I think it's a very important question and topic while we're here, because there's so much stuff that we can cover and we're starting to run low on time. So I want to make sure that we answer any of the questions that come up. So there's a lot of
Slide
content in here for you.
54.
Oh, fantastic. I can jump here real quick.
And just so everybody knows, standards are consensus, open and transparent based, done by usually a trade association of some nature, and then a legal entity like a municipality or a city, a state, a government accepts and uses that standard in their code.
Mhm.
So you will find locations that won't allow R290 units for certain locations.
Right.
Institutional is a big one, where
Yes.
we see even issues with A2Ls, where you have like a hospital or a jail where you have people that are in the structure that can't freely move about the structure. They're kind of isolated in an area. And if there is some sort of emergency, there is no access to egress immediately. So when you get into certain building, such as in what is zoned that way, you'll see that they severely limit the types of refrigerants and things. You'll have to use very small, very segregated systems throughout the individual systems throughout the facility.
Right. Instead of a larger connected
Yeah, instead of
systems.
one big unit doing the whole place, you might have 50 small units doing the place.
Right.
You know, this is a really good picture and it helps us understand a little bit about the charging. So if you look on the
next one, too.
left, this is actually a charging scale for our A3s, right? And you'll see the tap built into it. So we're talking about critical charges. A lot of times we're talking grams now. We're not talking ounces. So yes, we are going to be using smaller
Go to the next
diameter
slide.
hoses. We're going to be using scales that have the
There you
refrigerant
go.
built into it, or ways for it to be connected onto the scale. So there are going to be new tools that we're going to have to be looking. I'm okay with that. I like buying new
Yeah,
tools.
that scale is awesome. It really is. I wish they made, a larger version of that for the refrigerants we're using today, but
Yeah.
But one thing to remember is you still have to purge your hoses
Sure.
because you've got to get the air out of the hoses. Otherwise, you're just introducing it into the system.
Absolutely.
So yeah, you can see the hoses are 1/8 inch there, and we're using little access fittings. And in this particular model, the refrigerant goes through the scale. There's a solenoid inside of there, and you program in exactly what you need to put into the system, and it will open the solenoid, allow the refrigerant to flow, and then close the solenoid once it's done.
Love that. Starting
Yeah,
seeing
dude,
it on
so
our
do
larger
I. Dude,
applications
it's
too.
awesome.
I
Yes.
really like that idea. Very cool. We got a few minutes left. Anyone have any other questions? I know one
Can
of
you
them
go to
came
slide
in.
42?
Yeah,
One thing that
absolutely.
we have to point out is when you're sealing the system to take off the tap line,
Yeah.
you put a crimping tool on
Yeah, the pliers.
and you leave the crimping tool on. You don't know how many trainings I went to that they said, well, they couldn't braze over the crimped end of the access line because there was refrigerant coming out. And my first question was, did you still have the crimp tool on? Oh, no, I took that off.
Right.
So you
Until you're
crimp it
done. Yeah.
and
Absolutely.
you leave it on, and then you braze where you've crimped the end of the line, and then you take the crimp tool off, and then you leak check it again to make sure that you aren't leaking any 290.
Absolutely.
So
Great.
another
There we go.
question that comes up, Clifton, is the recovery. All
Yes.
right. In most cases, the hydrocarbons are exempt from the 608 recovery. We can vent them. All right. But it's not just where you're at. All right. You don't do it in a commercial kitchen where there's this, a flat top grill and open flames and all of that. You got to move the unit outside and vent it that way. You have to do it safely. If you could see, like what's listed here, it shows you a bunch of the different applications where you're allowed to vent this refrigerant.
All right. I was just getting some more resources out here so I can share some locations for our content. Let me hop on the online
We
store.
do cover a lot of stuff in this book, a lot of
Mhm.
the service procedures. Murph and I have gone through this pretty with a fine tooth comb. Okay, do this, don't do this. Here's the service procedure to do this. If you're going to recover, you can recover these refrigerants, but you have to have the right equipment and follow the right process of recovery there. Again, following the manufacturer's literature on that. So We do cover a lot of stuff in this book. It doesn't look like it's a really big book, but it is really packed with great information from a lot of reliable sources, trusted sources.
And you can find that book on escogroup.org. This is in the bookstore. You'll see it right here. It'll bring up all the information on the book. The PowerPoint that we were using today is part of the instructor resources for it as well. So we have a lot of content available for you. I know Paul's already got the book, and hopefully be introducing this into the classes here in the near future. And another question that came in, and it is kind of related to this one. Patrick was asking, we used R454B now. Why did we go away from R410 of a phase out? And where it's really comes down to the whole global warming potential aspect of it. So we went from a high GWP refrigerant of R410A to lower GWP refrigerants like R32 and R454B. And we will continue going into lower GWP refrigerants in all aspects going forward. So a lot happening
it was
right
part
now.
of federal legislation to nudge us along that path, so to speak. The AIM Act to regulate the HFCs in specific GWP. GWP is something you're going to have to become familiar with, because moving forward, not just nationally, but globally, all of our refrigerant regulations moving forward are going to be based on that number, that GWP number. So it's something we're going to have to become familiar with.
Absolutely. And yes, Paul, one of the questions came in, is the PowerPoint available for this A3 book? And yep, absolutely. So the one that we were using today are slides out of the A3 presentation that goes along with the book.
And Murph and I will have the exam. We're working on it. We're thoroughly working on it. We'll get there. There'll be a certification exam and a practice exam as well.
Fantastic. Well, we sure appreciate everybody joining us. We're going to be doing some work, some experimenting, some lab testing on an A3 unit here in the near future, making arrangements to get that A3 heat pump in here so we can start looking at some pressures, looking at some temperatures, getting comfortable with these as they're starting to be introduced into the industry. And we will see you all again next week on Did You Know, the ESCO HVAC show. Jason, Murph, I appreciate you guys joining us today.
Thanks for having us.
Absolutely. Everyone have a great evening, and we'll see you all next week.
See you later.
Bye.
Bye, everybody.